This is Algebra 2 4.1a to 4.1b Laws of Exponents. This is the 4.1a portion of our project. And again, I apologize for the Bandicam watermark that is going to be shown on the top of this video. But anyways, the 5 basic laws of exponents. Number 1, how to add variables with the same exponential value. Number 2, how to multiply exponents. Number 3, how to exponent exponents. So that's basically raising an exponent to the value of another exponent. If you don't understand this, we will go into further detail later. Number 4 is how to divide exponents. Number 5 is how to deal with the problem if the exponent is 0. Law 1, how to add variables with the same exponential value. The basic equation for this is a to the power of m plus a to the power of m equals 2a to the power of m. The variables a and m can be substituted with any real number, like any variable, so the equation would work. For example, if a was m and m equals 2, then the equation would be 1 to the power of 2, or 1 squared, plus 1 squared equals 2 times 1, because 1 is the a variable, to the power of 2. This equation would work because both sides would indeed equal 2. Law 2, how to multiply exponents. The basic equation is a to the power of m multiplied by a to the power of n equals a to the power of m plus n, or you can see the second equation there. I grouped m and n together just to make it more visually appealing because it still equals the same thing. And an example problem was if a equals 2, m equals 3, n equals 4, then the equation would be 2 to the power of 3 times 2 to the power of 4. Or this would equal 2 to the power of 4 plus 3. And 4 plus 3 equals 7, so 2 to the power of 7 would equal 128. And it would be the same on the other side. Now you have to remember this, the base has to be the same for this to work. For example, 2 to the power of 3 times 3 to the power of 2 does not equal any of those crazy numbers, or even having it like 2.5 to the power of 5, because the base number has to be the same to add the exponents. Law 3, how to exponent exponents. Like I said before, this is raising an exponent to the power of another exponent. So the basic equation would be a to the power of m to the power of n, and a to the power of m is inside the parentheses because it needs to be together when it is raised to the power of n. And that would equal a to the power of n times m, and yes, the star is a multiplication symbol. So, this is an example of the equation in its simplest form. X to the power of 2 to the power of 4, so that's basically x squared 4 times, so x squared times x squared times x squared, and you get it. And x squared is basically x times x, so it's just split up there, x times x 8 times, and that would come up with x to the power of 8. And the example problem at the top, if a is 2, n is 3, m is 5, then the equation would be 2 to the power of 3 to the power of 5, or 2 to the power of 3 times 5, which 3 times 5 is 15, so 2 to the power of 15 equals 32,768. And the other examples are there if you just want to look at it. Law 4, how to divide exponents. The basic equation is a to the power of n divided by a to the power of m divided by a to the power of n equals a to the power of m minus n. For example, if a is 2, m is 3, n is 1, then the equation would be 2 to the power of 3 divided by 2 to the power of 1 equals 2 to the power of 3 minus 1. Now 3 minus 1 is 2, of course, so 2 to the power of 2 would equal 4. And if you don't believe me, you can look at the other side. 2 to the power of 3 is 8, divided by 2 to the power of 1, which is 2, which means 8 divided by 2 equals 4, so it would check out. Law 5, dealing with an exponent equal to 0. Now this is a very simple concept. If the exponent's value is 0, then the stuff inside will always equal 1, except for 0, but that's another rule. For example, you can see all that junk in the middle does not matter as long as it doesn't equal 0. If it's raised to the power of 0, it will equals 1. So it doesn't really matter what is inside the parenthesis. And that is my project. Hope you enjoyed.